All right, this is your first lesson of topic B, so this is lesson 10. By the end of this lesson, you're going to be able to represent a proportional relationship in a table and create an equation from that table. You'll know you're successful when you can take a word problem, create a table of values from that, find a constant rate within that table, use that constant rate to write an equation, and then apply the equation to other situations, okay? So today you are going to review some skills with me that you learned in 6th and 7th grade. I'll go through 3 examples. We'll do 3 exercises. Then we're just going to close out the lesson and you'll complete your exit ticket. Alright, so welcome to this lesson. The first thing that we're going to do is review some things you learned in 6th and 7th grade about ratios, ratio tables, and just proportionality in general. Okay, so we have this question. It says, Paul walks 2 miles in 25 minutes. You can see that they've already started this table and they've put those 2 values in this table. The question asks us, how many miles can he walk in 137.5 minutes? Okay, so before we go forward, I just want to identify a few things that they've done. If you can think back to 6th and 7th grade, you know that in a table, your x values always come first, your y values always come second. So x is always on the left, y is always on the right. Okay? Now, where people sometimes have trouble with this is identifying what goes on the left, what goes on the right. Okay, why didn't they put the 2 on the left side and the 25 on the right side? And the reason being is that we always want to have our independent variables represented by our x. So I'm just going to quickly put this as our independent. And our dependent variables are always on the right. Okay, and you might be thinking, well, how do I know the difference between an independent and a dependent variable? If you think of somebody who's independent, they're not, nobody's influencing them, right? It doesn't matter what everyone else is doing. They're still doing their own thing. So if I look at miles and time is always independent of everything else, right? Time's going to go at the same rate it always goes at. Whether you're, waking up on time and ready to go, or whether you're running late, time's ticking at the same speed. Okay, so this is always independent. So time is always independent of everything else. And in this case, the amount of miles he walks depends on how long he walks. Okay, so that's why that's dependent in this case. So, time is always independent. That means it always comes first. That means it's always our x value. And you'll get the hang of this as we go on. If this is something that you kind of get stuck up on, it's a really minor thing, and you'll figure it out the more you practice with this. Okay? So we have this table. We have our independent variables on the left, which is time, and our dependent variables on the right, which is distance. And the original ratio they give us is that he can walk 2 miles in 25 minutes. So they've gone ahead and they've entered those values into this table. All right? Now, you learned in 6th grade that you can manipulate this table to find different values. So you can say, what if I double this 25, if I times it by 2? Well, I get 50. Well, in 50 minutes, how would I know how many miles he walks? Well, you just double this side. Okay, you apply the same operation. So if I doubled 2, I would get 4. Okay, and you could keep doing that, right? You could say, okay, well, what if I tripled it? I did times 3. 25 times 3 is 75. Well, I'd do times 3 on this side, and I would get 2 times 3, 6. And you could keep doing this. You could find out a bunch of different proportional relationships between time and distance that follow that same constant rate of the first ratio they gave us. However, if you look at the question, it gives us a number. It says, how many miles can you walk in 137.5 minutes, which is not an equal increment of 25. So we're going to have to find a different way to do this. And this is what you learned in 7th grade. So in 7th grade, you learn that something goes on between our x and our y value. And what's happening between these values, instead of looking at going down on our table, we're going to look at at going across. Okay? There's something happening between these two numbers. And if we find out what that is, we can just apply it to every single row and we can get the correct proportional relationship every time. Now what this is called is our constant of proportionality. Super long word, and there's a lot of different names for it. But this is what you learn to call it in 7th grade, okay? Another name for this is your rate. Another name for this is your unit rate. We also call this our rate of change. And pretty soon you're going to start calling this your slope. Okay, there's a bunch of different names for it, a bunch of different variables for it. But for the time being, the variable that I'm going to use, because we're going to start using this, is just m. So anytime I'm using m, I'm just talking about this number that gets us between x and y. Now, if you go from x to y, you multiply by m. If you're going from y to x, you are dividing by m. And that's super important for many reasons. You just always want to make sure you're doing the correct operation. So left to right, from x to y, you multiply, y to x, you divide. Now you might be thinking, well, how do I find this constant or this unit rate or this slope or m? How do I find m? Well, you use the values that they gave you at the beginning. The original values they gave you, you can use to find m. So in this case, 25 times something equals 2. Now that's a lot smaller. It's getting smaller as we go, so I know they're going to be multiplying by a decimal. Now another way to find this is just to do 2 divided by 25, right? We're going backwards. We're working backwards. So the formula for our constant, our rate, our unit weight, whatever you want to call it, is y divided by x. So this is the formula we will use. If we take our y value, we divide it by our x value, we get our slope. We get our constant. So in this case, I'm going to do 2, because that was our y value at the top, divided by 25. And if I did this in my calculator, I would get the fraction of 0.08. Okay? So my constant of proportionality for this table is 0.08. And you'll see that if you do 0.08 for each of these rows, it's going to work, whether you divide it from going from your y to your x, or you multiply it by going from your x to your y. So if I did 25 times 0.08, I'll get 2. If I do 50 times 0.08, I'll get 4. I could even work backwards. I could do 4 divided by 0.08, I'll get 50. Okay? So this number is our unit rate. It's our proportional relationship between these two numbers. And so we can apply that to any other number we want, and we'll get the correct corresponding number that follows the same relationship. So in this case, they said, how many miles can he walk in 137.5 minutes? So I'm going to plug that in here, 137.5 minutes. And I'm trying to figure out this value over here. I don't know what that is. But I do know what my constant of proportionality is. I'm going to erase this real quick so I have some space. My constant of proportionality I found was 0.08. Okay? Now, I'm starting on my left side because I'm starting with a value on my x column. So I'm going to do 137.5 times 0.08, and that will give me my answer on the right side, y. So 137.5 times 0.08, if I do that in my calculator, I get 11. So when this person, Paul, walks 137.5 minutes, he ends up walking 11 miles. Okay? The last thing I want to teach you from this equation or this table is how to write the equation, because this is something you're going to have to start doing. And so in this case, when we're writing our equations, we always want to start with y. So y equals, how do we get to y? How do we get to this value right here? Well, we did our x times 0.08. I keep writing 8. And that gave us y. So y equals 0.08 times x. So this is the equation for this table. Whenever we want to figure out what y is, we just take our x value and we times it by 0.08. So all we had to do was find this constant, and we were able to write our equation. Okay? Again, this is just some review from 6th and 7th grade. We're going to be adding in some graphing for 8th grade, and so we'll do that in the coming slides. All right, so here's our first example. It says the equation that represents how many miles, y, so they're saying that y is our miles, they put that right here. Dave travels after x hours, so time, right, that's our independent variable, is y equals 50x plus 15. So they've already given us the equation. That's kind of nice. We didn't have to create that on our own. They said that to get to our y value, we have to take our x value, times it by 50, and then add 15. So we're just going to use this equation to complete this table below. This is just to kind of get you familiar with filling out these tables. So the equation for this is y equals 50 times x. So on the second row, what's my x? My x is a 2, so it's going to be 50 times 2 plus 15. Okay? And I'm just going to solve that. So y equals, to my multiplication first, what's 50 times 2? 100 plus 15. What's 100 plus 15? 115. So when x is 2, y is 115. All right? We'll do that with our next row. So y equals 50 times x. In this case, x is 3. And then we're adding 15. Okay? Now 50 times 3, 150. And we're adding 15. 150 plus 15, you can do it in your calculator. You can do it in your head. It's 165. Okay? Now the next one is a decimal. So I'm probably going to use my calculator for this just because I want to be sure that I'm doing it correctly. But I'm just going to follow the same process. So my equation was y equals 50x. So this time my x is 3.5, so it's going to be 50 times 3.5 plus 15. In my calculator, I'm going to do 50 times 3.5. And I get 175. So y equals 175 plus 15. So if I add 15 to that, I get 190. Okay? And then the last one here, I'm going to do 4.1. So y equals 50 times 4.1 plus 15. So I'm going to do 50 times 4.1. I get 205. And I'm still adding that 15. So I get 220. So this slide was just to kind of help you practice using a linear equation to find proportional sets of numbers. So basically this table tells me that in 4.1 hours, Dave walks 220 miles. Okay? In 3.5 hours, he walks 190 miles or travels 190 miles. I don't think he's walking. But yeah, this should help you practice a little bit with creating these tables based on your equation. All right, here's actually what your questions today are going to look like. So for the rest of this lesson, they're going to look like this, and your exit ticket is also going to look like this. So it says, Wesley walks at a constant speed from his house to school, 1.5 miles away. It took him 25 minutes to get to school. I'm going to mark my boxes because I'm going to close read this. So I read for the first time. Next time, I'm going to kind of underline some things, annotate it a little bit. So Wesley walks at a constant speed. What does that mean? It's proportional. Okay, so I'm going to be able to find a constant for this ratio. He is walking from his house to his school, and it's 1.5 miles. So that's part of my ratio. okay? And it took him 25 minutes. That's the second part of my ratio. Okay, so my relationship here is for every 1.5 miles, it takes him 25 minutes. Mark my second box. And then the third time I read, I'm actually going to start answering some of these questions. So I can already see that the first question says, define my x and y variables. Now, Wesley walks at a constant speed from his house to school 1.5 miles away. Is this independent or dependent? Well, let's look at the other number. It took him 25 minutes. If you think back to what I said earlier, time is always independent. Okay? Nothing can affect time. It's always going to tick the same way it ticks. But the speed at which someone walks, how far they walk, that can change. So the fact that he walks 1.5 miles depends on how long he's walking. Now also, if you think back to the first couple of slides, if something's independent, it comes first. So in the alphabet, x comes first. So this is going to be my x value. And if something is dependent, it's depending on something that comes before it. So this is my y. I'm going to go ahead and mark my third box. I did my close reading, and I'm going to answer this first question. Define your x and y variables. So x is going to be time, minutes. Okay, and y is going to represent miles or distance. And we're measuring that in miles. Okay. B says create a ratio table and find the constant. So I'm going to do this off to the side here. First, I always put my x, and then I put my y. Well, what does x represent? Minutes. What does y represent? Miles. And from there, I'm going to start my table. I'm just going to use the first two numbers they gave me. So they said 1.5 miles away. Takes him 25 minutes. All right. So I've made my table. The next part of that question said find the constant. So find the number that gets us back and forth. What is my m? What is my constant? If we go from here to here, we're multiplying it. If we go from here to here, y to x, we're dividing by it. So the formula for constant, or the formula for slope, is y divided by x. So I'm going to do y divided by x. In this case, my y is 1.5, so it's going to be 1.5 divided by 25. 1.5 divided by 25. I'm going to do that in my calculator really quickly. I get 0.06. So 0.06 is my constant. And again, we also can call this my slope. It equals m, but this is my constant. So the number, I'm just going to erase this real quick, that's getting me back and forth between these two, is 0.06. And you can check it if you want. Is 25 times 0.06 1.5? Yes. Is 1.5 divided by 0.06 25? Yes. All right. It says use the constant you found in part B to create an equation. So I'm always going to start my equation by saying y equals. So y equals what? What do I have to do to get to y? Well, I'm going to start with my x, right? And then I'm multiplying something by that x. What did I find that I was going to multiply? This, 0.06. So you can either do x times 0.06, you could do 0.06x, but these two numbers are being multiplied. So this is my equation. Y equals 0.06 times x, or 0.06x. Okay? And then it says, use the equation you created in part C to solve the following question. How many miles did Wesley walk after 15 minutes? So it gives me this new piece of information. It says, what about 15 minutes? How far would he walk then? So I'm going to plug this into my table and say, okay, 15 minutes. I want to figure out what goes here. And I'm going to do that by applying this constant of proportionality. So I'm trying to find y, right? So y equals 0.06, my constant, times x. Well, what's my x in this case? 15. So this becomes y equals 0.06 times 15. I'm going to do that in my calculator really quick. I get 0.9. So how many miles did he walk after 15 minutes? Just under 1, right? He walked 0.09 miles in 15 minutes. Sorry, 0.9 miles. And that's my answer here. It follows my proportion. Okay, and I could check it by dividing by that 0.06 or multiplying by that 0.06. Example 2, we're doing the same thing just with a different group of numbers. It says Stephanie drove at a constant speed from her apartment to her friend's house 20 miles away. It took her 45 minutes to reach her destination. Read for that first time now. I'm going to be identifying the numbers I'm going to use here. So Stephanie drove at a constant speed. That means there's going to be a proportional relationship. To her friend's house 20 miles away. So she drove 20 miles. It took her 45 minutes. So that is my ratio here. Okay? Now, Stephanie drove at a constant speed from her apartment to her friend's house 20 miles away. It took her 45 minutes to reach her destination. I know that this is time, so this is my independent variable. And I know that this is distance, so this is dependent on how long she drives. Okay? Mark my third box, and I'm going to go ahead and get started solving this. It says define your x and y variables. Well, I kind of already did that, so I know that independent comes first, so this is x. Dependent comes second, so this is y. So x, in this case, is going to represent time. And we're measuring that in minutes. And y, in this case, is going to represent distance. And in this case, we're using miles to measure that. Okay, done with part A. Now it says create a ratio table and find the constant. So I'm going to do that real quick. I have x, y. X is my time, and we said that's in minutes. And y is my miles, and that, sorry, y is my distance, and that's in miles. So these are my two columns. And I'm just going to plug in the values they gave me. They said 20 miles in 45 minutes. So from here, I'm going to find my constant of proportionality, or my slope, or my unit rate. All of those words mean the same thing. So to do that, do y divided by x, and that's going to give me my constant rate. So my y value was a 20, so I'm going to do 20 divided by my x value, which was 45. And what does this give me when I put it in my calculator? 0.4 repeating. So the constant rate that's getting me back and forth between my x and my y value for every line in this entire ratio table is going to be 0.4 repeating. If we go from x to y, we'll multiply, and if we go from y to x, we will divide. Okay. Now it says use the constant that you found in part B to create an equation. So I'm going to start with y. I'm going to say to get to y, I have to take 0.04 and multiply it by my x. Sorry, 0.4. I keep adding an extra 0. So anytime we want to figure out what y is, we just multiply it by 0.4. Okay? Now in the same case, anytime we want to find out what x is, what will we do? We would divide. So x is y divided by 0.4. So we could actually write two equations, one for y, one for x. Okay? Now part D says, use the equation you created in part C to solve the following question. How long would it take Stephanie to reach the halfway point between her house and her friend's house? Now halfway, it was 20 miles to get there all the way, so halfway would be 10 miles, right? And it's saying, how many minutes is that going to take? So we're trying to solve for x, so we want to know what x equals. So I'm going to use this equation that I made, the one for my x. So x equals y divided by 0.4 repeating. I'm just going to rewrite this down right here. Remember, 0.4 repeating is not the same as 0.4. This is 0.44444444. So we have to make sure we use that. All right, so it says, take your y and divide it by 0.4 repeating. So what's the y value that I'm using here? What's the number of miles I'm trying to find? 10. So it's going to be 10 divided by 0.4 repeating. If I do this in my calculator, again, I have to type in a lot of 4s. So I'm going to do 10 divided by 0.44444444. Do it as many times as I can, and then I'm just going to press enter. And what I got was 22.5, and then there's a bunch of zeros. I'm just going to round it off to 22.5. And I'm going to add this into my table. So to drive 10 miles, it's going to take her 22.5 minutes. And I could check this by going from x to y. I can say, is 22.5 times 0.04 repeating, so 0.4 repeating 10? Yeah, I get 9.9999999, and that rounds up to 10. So it'll take 22.5 minutes to go 10 miles. That's my answer. All right, you guys are going to now complete exercise 1. It's pretty much the exact same thing that we've just been doing. It says, Emin walks from the store to her friend's house 2 miles away. It takes her 35 minutes. I want you to define your x and y variables, create a ratio table and find the constant, use the constant to create an equation, and then I want you to try your hand at actually using that equation to answer a question. I'm going to give you 4 minutes to do this before we go over it. All right, going over this, I just want to answer part A. So it told me that her friend's house is 2 miles away. It takes her 35 minutes. So I know that my x is my independent variable, and that represents minutes. My y is my dependent, and that represents miles. From there, I started to create my ratio table off to the right. To find my constant, I'm going to do y divided by x. So in this case, this becomes 2 divided by 35. And when I do that in my calculator, I get, 0.57. And I'm just going to round it off there. So my constant here, my slope, my rate of change, my unit rate, whatever you want to call it, is 0.57. I'm going to put this in the table so that I can see it. All right, now that I have my constant of proportionality, I'm going to use that number to create an equation. I'm actually going to create 2 equations. I'm going to start with my y. So if I ever want to get to y, I'm just going to multiply x by that constant. So it's just going to be my constant times x. If I ever want to get to my x, I'm going to divide that constant from my y. So I'm going to do y divided by 0.57. Okay, and basically this just represents what I have at the top of my table up here, right? To go from x to y, I multiply. by 0.57. To go from y to x, I divide by 0.57. All right, from here I'm going to answer this question. It says, how many miles does she walk in 10 minutes? So I've gone ahead and I've put my 10 minutes into my table, and I'm trying to find y. I don't know what y is, so that's what I'm going to use this first equation, where I find my y. What am I going to do? I'm going to do 0.57 times x. So y equals 0.57 times x. In this case, my x is a 10, so it's going to be y equals 0.57 times 10. And when I do that, I get 5.7. So my answer, how many miles? 5.7 miles in 10 minutes. And that's it. All right, you are now going to do the same thing for exercise 2. A little bit different question, but you're going to take 4 minutes to do this, and then we'll go over it. All right, now that it's been 4 minutes, I'm going to solve this for you, kind of go through it. Okay, so for part A, I went ahead and I found my independent and dependent variables, labeled those x and y. My x variable represents minutes, and my y variable represents miles. All right, so for part B, I've gone ahead and I've created my ratio table off to the right side based on what I've identified, and I'm going to find the constant. So remember, the constant is y divided by x. So in this case, it's going to be 4 divided by 80. And when I do that in my calculator, I get 0.05. So this is that number that's going to be getting me back and forth between my x and y values in my table. 0.05. We go from x to y, we'll multiply, go from y to x, it'll divide. And based on that information, I'm going to create my equation. So for the first one, I'm going to do y. So if I'm trying to get to y, I'm going to start with x. What am I going to do with that x? I'm going to times it by 0.05. So it's going to be 0.05 times x. Okay? And if I were going to be trying to get to x, I would be starting with my y, and I'd be dividing by 0.05, my constant. So these are two equations that represent this table. Okay, in the last part, part D, it says use that equation I created to solve the question, how far does Aaron walk in 30 minutes? So I went ahead and put 30 minutes into my table. And what I'm trying to find is y. I'm trying to find how many miles. So I want to figure out what y equals. So I'm going to use this equation, the one that says y equals. So y equals 0.05 times x. In this case, my x is 30. It's going to be 0.05 times 30. And when I put that in my calculator, I get 1.5. So what this means is after 30 minutes of walking, he's going to be done with 1.5 miles. And that's my answer. Okay, this is your last exercise before your exit ticket. So again, take 4 minutes to solve this, and then we'll come back and go over it together. Okay, so for part A, I went through, I did my close reading, I found my independent and dependent variables, and I realized that my independent variable for x represents minutes, my y for my dependent variable represents miles. For part B, I've gone ahead and I've created my ratio table with those values off to the right, and now I'm going to find the constant. To find the constant, I take my y and I divide it by x. So in this case, it's going to be 1.3 divided by 7. If I do that on my calculator, 1.3 divided by 7, I get a huge decimal, and I'm just going to round it off, 0.1857. So I'm just going to round this off to 0.186. Okay? So that is my constant. I'm going to add that into my table so that I see that I'm always going to be using this number, 0.186. And if I'm going from x to y, multiply. Going from y to x, I divide. All right, this brings me to C, where I'm going to create my equation. So if I'm ever trying to solve for y, I'm going to take 0.186 and multiply it by x. So that's going to be my equation for y. If I'm ever trying to find out what x is, I'm going to take my y value and I'm going to divide by 0.186. So those are my two equations. All right, so based on this relationship, based on my equations, it says to answer this question, it says how much time does it take Erica to drive 1 mile? So I went ahead, I put 1 mile in the appropriate column. So I know that I'm trying to find x. I'm trying to find out how many minutes that takes. So if I'm trying to find x, I'm going to use this equation, the one that says x equals. So it says x equals y divided by 0.186. Now the y here is 1, so that's going to be plugging in here, y equals 1 divided by 0.186. And I'm just going to do this in my calculator. 1 divided by 0.186. What do I get? I get 5.376. I'm going to round this off to 0.38. So 1 mile is going to take 5.38 minutes. And we're done with this exercise. All right, your exit ticket today is pretty much exactly what we've been doing for this entire lesson. You're going to read this question, define your x and y variables, create a ratio table and find the constant. Use that constant to create an equation, and then use the equation to answer the question at the bottom. Please take your time, look back at the work we've done already throughout this lesson to kind of help you. And yeah, good luck. I think you guys will do well with this.